Up to this point, many of us have been taught that light behaves as a wave. But what if I told you that under some circumstances, light actually behaves as a particle? Einstein theorized that light is made up of particles known as photons, and the flow of photons moves in a wave. At the time, this theory opposed a lot of the prevailing theories of light behaving solely as a wave, until a scientist by the name of Arthur H. Compton helped to solidify the belief that light behaves as a particle using a phenomena now known as Compton scattering or the Compton effect. Compton did so by observing the way X-rays scattered when colliding with electrons in a carbon target. During his research, he assumed that light had a particle nature and discovered that when high-energy photons collide with electrons, an elastic collision occurs, where both energy and momentum are conserved. The energy of the photon is equal to Planck's constant multiplied by the photon's frequency, and the momentum of the photon is equal to Planck's constant divided by the photon's wavelength, or the photon's energy divided by the speed of light. In order to conserve both energy and momentum, the photon must experience a shift in wavelength. This would not be possible if light only behaved as a wave. But if a particle nature of light is assumed, a shift in wavelength makes sense as some of the photon's energy is imparted on the electron during the collision. This makes the photon's final wavelength longer than its initial wavelength. In the situation described by the Compton effect, both the photon and the electron scatter off at an angle after colliding. So, the shift in the wavelength of the photon can be represented by the equation lambda prime minus lambda equals h over mc multiplied by 1 minus cos theta, where lambda prime is the wavelength of the photon after the collision, lambda is the incident wavelength, h is Planck's constant, m is the mass of the electron, c is the speed of light, and theta is the scatter angle of the photon. So, thanks to Arthur Compton and the Compton effect, I think we can agree that light behaves both as a wave and as a particle.